Hello, your video today is on scientific notation. You will be able to write numbers in standard and scientific notation. That's the first part. And then the second part is you will be able to compare numbers using scientific notation. First thing we need to talk about is what scientific notation is. It is a shorthand way to write very large or very small numbers using powers of 10. And down here we have the form that it's written in. You have a number A, and A is between 1 and 10. It can be the number 1, but it cannot be the number 10. It has to be in between. And then times 10, and 10 is raised to the nth power, and n has to be an integer. Positive or negative, doesn't matter, it just needs to be an integer. So now that we know what the format is for scientific notation, we're going to determine whether or not the three examples here are. So here's our first one. The first thing you're going to look at is A, which is 23 hundredths. That is less than 1, so we can automatically say this is no, we don't have to look any further. Second example here, 2.3 times 10 to the 7th. Look at A, that's between 1 and 10. We're multiplying by 10 to the 7th power. We can do that. So your answer here is yes. That is scientific notation. And the last one, 9.3 times 100 to the 9th power. Look at A first. That is between 1 and 10. Times 100 to the 9th. 9 is a integer, but 100 is never what you're going to multiply. We're using a base of 10 and not 100, so the answer to that one is no. Alright, so now that you know that formula, or I guess it's not really a formula, but the way of writing it. Alright, writing a number in scientific notation is kind of fun. First example here, the distance between the Sun and Saturn is a really big number. That would be 1,430,000,000 kilometers. And so what we're going to do is, because we want to get, the first thing we want to do is move the decimal point so that we have a integer number between 1 and 10. So our imaginary decimals here, we're going to move it all the way up here, because if we put a decimal there, then we have 1.4, which is a number in between 1 and 10. We couldn't do it any sooner or later than that, because if we put it behind the 4, that would be 14, which is greater than 10. And then if we were to put it in front of the 1, that would be 0.14, which is smaller than 1. So that is not the choices. So now we have 1.43. And now you eliminate all the zeros in a way. You count how many place values it took you. So you had 1, 2, 3, 4, 5, 6, 7, 8, 9. It moved 9 places. So we're going to say times 10 to the 9th power. Next one, the radius of an atom is really small. And so we want to go move the decimal until we hit a integer. And if we were to move it here, that would be 0.1, which is, again, not between 0 and 1, so we can't do that. So we're going to keep going. We're going to put the decimal point here, because that's 1.0 at that point. So we have 1.0 times 10, and then how many decimal places did I move that? Would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I moved it 10 times. So another way you could just say this is 1 times 10 to the 10th power, would be your answer. Oh, and then I almost forgot. Because we're moving the decimal place to the right, we're dealing with really small numbers, fractional numbers, we need to have a negative exponent. So really big numbers are always positive. Really small numbers are always a negative exponent. So don't forget that, because I almost did. Your turn. Please write these two examples in scientific notation on your paper. Make sure you're showing your work too. And then we'll move on. Alright, writing a number in standard notation. Standard notation is how you typically see numbers, but you're going to go from scientific to standard. So here we have the weight of an elephant is 5.5 times 10 to the 6th grams. And I know that's a really big number because my exponent is positive. So what I'm going to do here is take my 5.5, the decimal was here, and I'm now going to move it 6 times. 1, 2, 3, 4, 5, 6. Decimal now is here. And then I'm going to add in zeros for all of those place values that I moved, which gives me then, I'm just going to write this a little bit nicer, 5,500,000 grams for an answer. The weight of an ant, 3.1 times 10 to the negative 3rd grams. Because I see the negative 3 there, I know that I am dealing with a really small number. So I'm going to first write out what I'm told, which is A, which is 3 and 1, 3.1. Okay, now I'm going to move the decimal the opposite direction because I'm going backwards. 1, 2, 3 times. Decimal now goes here. Add in the zeros. Just going to write this a little bit nicer. And there is my answer. Your turn again. Please write the following two questions in standard notation. Right, now that you have completed all of that stuff, you're going to go onto my website under my calendar where you got your video, and there's going to be a line that says Google Form, and you're just going to click on that. You're going to enter all of your answers to your practice problems in order on that page, and then that way I know what your answers are without having to look at your paper. Make sure all of your work is on your paper though, because you're just entering answers online. Now that we know how to write numbers in standard and scientific notation, we have to compare them. And when we're comparing numbers that involve scientific notation, there's two steps that you're going to take. First, you're going to compare the powers of 10. So obviously if we have 10 to the 6th power and 10 to the negative 2 power, the 10 to the 6th power is bigger for obvious reasons. If they are the same power, if they're equal, then you're going to look at the decimal numbers, and that will tell you what the correct order is. So that's the steps that you're going to follow. The example we're going to do is this one. What is the order of the oceans in greatest, from least to greatest surface area? And there's pictures here. You can see them. So the first thing I'm going to do is compare their powers of 10, and as you can see, these two are 10 to the 7th power, and then these two are 10 to the 8th power. So I automatically know the Atlantic and the Pacific are bigger, and you probably knew that anyways, I would hope. And so now we're going to compare the next two, and you're going to compare the decimals. So I have 7.94 and 1.41. The decimal 1.06 is smaller than 7.49, so I'm going to, 1.41 is smaller than 7.49, so my least one is going to be the Arctic. And I can't spell, apparently. Let's try that again. Okay, followed by the Indian Ocean. And then I have to compare the Atlantic and Pacific because those two are both 10 to the 8th power. 1.06 is smaller than 1.8, so I know the Atlantic is next, and then the Pacific is the largest ocean. Same concept, same process holds true when you are ordering numbers. What you're going to do is compare them, compare their powers, and then look at the decimals. If you have numbers that are in scientific notation and numbers that are in standard notation, you will have to do some converting there. You're going to either put them all in standard or all in scientific so that you are working with the same types of numbers. So here we go. I'm going to put all of these into scientific form because they're almost all there. If you look at 49.7 to the 10th, or times 10, we can write that as a power of 10. I just have to move the decimal one more time. So this is going to be 4.97 times 10. And there is an invisible 1 on there, 10 to the 1st power. So this is now going to become 10 to the 2nd power. The next one is in good standard, what's expected of scientific notation. The next one, though, is not because our A value is less than 1, so we need to put that into notation. So we need to move this decimal 2 times, and because I moved it 2 times, this now becomes 4.7 times 10, and I went to the right, which means I'm decreasing, so this is going to be 10 to the 7th, and then this last one would really, if you think about it, be 10 to the 0 power, because 10 to the 0 is just 1, and 495 times 1 is 495. But then we want to put that into scientific notation as well. Move it twice, move the decimal twice, and we get 4.95 times 10. And then it was to the 0 power, but I moved it twice to the left, so it now becomes 10 to the 2nd power. Now that these are all in scientific notation, we can put them in order. So here we're going to compare exponents first. So we have 10 to the 2nd and 10 to the 2nd. That's going to be the smallest. And then we compare decimals. And then 4 and 95 hundredths is smaller, just a hair. So this is going to be the smallest, which is, we'll put this as number 4. And then this one would be the 3rd. The next two are, again, 10 to the 7th and 10 to the 7th. But this one is smaller, so that's number 2. And then this is number 1, which is the biggest of them. The big thing is just make sure you're putting them in the right order, if it's least to greatest or greatest to least. Alright, your turn. You are going to put these in order from least to greatest. Make sure that you are comparing them correctly. And then you will enter your answer onto the Google form found on my website.
You have reached the end of your video. Write my name, Kyan, in the question box.